myclass.com.
Welcome back to myclass.com. Our topic, sparse matrix and its representation. A matrix is a two-dimensional data object of m rows and n columns, therefore having total m into n values. If most of the elements of the matrix have zero value, then it is called a sparse matrix. Let's see. A matrix is there with the 5 rows and 5 columns. So total 25 elements are there. In this 25 elements, only 2 elements are non-zero value. All other elements, the 23 elements are zero values. Then we can call this matrix is a sparse matrix. So how we are representing a sparse matrix? We can only store the value of a non-zero value and the row and column value of that particular element. Hence, we can have two advantages for sparse matrix representation. First is storage. There are lesser non-zero elements than zeros, and thus lesser memory can be used to store only those elements. If non-zero elements are very less, like 2 non-zero numbers are there, let's assume that our array contains 100 elements, but among that 100 elements, only 5 elements are non-zero values. We can only store that 5 elements and its index value, not all the zeros of that sparse matrix. So we can reduce the memory usage, and computing time also we can reduce. We can save it by logically designing a data structure traversing only non-zero elements. We can create a sparse matrix. We can represent a sparse matrix to another data structure with the contain only the non-zero values and its specifications. Clear? So let's assume that this is our sparse matrix A with 4 rows and 5 columns. So total 20 elements are there, but among 20 elements 1, 2, 3, 4, 5, 6 non-zero values are there. How it is representing in a memory? So sparse matrix representation in a memory like with the contain a 3 row elements, 3 row array, like so S with the 3 rows and how many non-zero values are there in the sparse matrix? That number of columns should be there for its new style matrix, new matrix, like 6 elements are there. Clear? So 3 rows are there and 6 columns are there. So our sparse matrix representation is like with 3 rows and 6 columns, because only 6 elements are non-zero values in this particular sparse matrix. So our rows contains, this is the row numbers and this is column numbers of that particular non-zero value. The 3 is a one non-zero value. It is in the 0th row and second column. 3 is the 0th row, 4th column. 4 is the first row, second column. 5 is there. Like that we are all saving this non-zero value. Hence, we can reduce the number of storage elements in a computer memory. Clear? Here, total 20 elements are there. In this type of representation, we can only have 3 into 6, 80. In this example, only 2 memory space is less when compared to this. But when we are talking about a 2D array with high index value like 100 rows and 100 columns are there, among that 10,000 values, if the very small 5 or 10 elements are non-zero elements, we can represent that type of sparse matrix like this. Okay. So this is all about sparse matrix and its representation. Now we are going to discuss about the program of sparse matrix implementation. A C program for sparse matrix and its representation. Our program start with the header files #include stdio.h and #include conio.h in void main function. First we are declaring a matrix for sparse matrix, and this variable for the order of that matrix mn and size is an integer variable for holding how many non-zero values are there in the sparse matrix. First we are entering number of rows m, then we are entering number of columns n, and now we are going to enter sparse matrix values. Okay, so 2 loops are there because this is a 2-dimensional array. I and I loop for I and loop for j. For I equal to 0, I less than m, I plus plus. Inside that inner loop is starting for int j equal to 0, j less than n, j plus plus, and we are scanning all sparse matrix values. Okay, after closing this loop statement, we are going to check how many non-zero values are there in this particular array, two-dimensional array. Again, we are starting one loop, and there is an inner loop and there is an outer loop. In this, we are checking each element, element is 0 or not. If it is not equal to 0, we are incrementing the size value. Our aim is to calculate how many non-zero elements are there. Now, we are defining other final matrix with the 3 rows and what is the size, value of size, that much columns are there in this matrix, and also int k equal to 0 for its representation, for its implementation. Again, we are starting an outer loop and an inner loop. If I equal to 0, I less than m, I plus plus, j equal to 0, j less than n, j plus plus. We are checking each element, sparse matrix. So, if I equal to 0, here j equal to 0, if we are checking the first 0, 0 value, sparse matrix 0, 0. If it is not equal to 0, we are saving that row number and the column number into that particular matrix with the name mat itself. So here the first the k value is 0. So we are saving the I value into matrix 0, 0. Now in the second row and second row and 0th column, we are saving the column value of that non-zero number. Then we are saving that non-zero number into as a third row. Okay. Then we are incrementing the k value. So now k became 1, and we are checking the other non-zero elements in that matrix. If other non-zero elements encountered, we are saving that also, the number of rows, number of column, and this value itself into the matrix named 2D array. If all the elements checked and if the all elements traversing is finished, we are coming from the two loop, the outer loop and the inner loop and the outer loop. Clear? So this is the main statements for its matrix representation, sparse matrix implementation. We are traversing all the elements of our sparse matrix which contains loads of zeros. If non-zero number is the non-zero value is there, we are saving the row value and the column value of that non-zero element and the value itself as a first column value. Then we are incrementing the column value. Again we are saving this details as a second column. Again we are saving again as a third column. Like that we are saving all the non-zero values. Clear? Now we are displaying the final matrix. Only 3 rows are there, and how many columns are there? Size, that much columns are there. We are printing each element, and we are giving space in between elements. And okay, clear? Now we will see how it's work. We are going to run this particular array. We are going to run this array. Our name is sparse.c. We are executing sp.exe. Enter the number of rows. Let's see, 3 rows are there, 3 columns are there. The values are 0, 1, 0, 0, 0, 0, 0, 0, 0, 9. Okay, so only 2 elements are there. So the 3 rows and 2 column matrix should be displayed here. See, in 0th row as a second column, here 1 value is there. In the second row, first column, 9 values there. So this is the sparse matrix representation. Clear?